Okay, well, it looks like everything's up and running. We've got a cube-shaped satellite has a side length of 10 centimeters. What is the least amount of aluminum needed to cover the satellite? So this is a question of surface area. And what you need to know is that there's 6 squares that make up a cube. And each of those squares is 10 by 10. And so if we go 10 times 10, that's 100. So we're looking at 100 square centimeters. But we've got 6 of them. So we go 6 times 100, which gives us 600 centimeters squared. So your friend finds the surface area of this prism. Is your friend correct? Explain your reasoning. So if I just do some quick math here, we're going 6 times 2 plus 6 times 3 plus 2 times 3, and then we're going to multiply that by 2. Then we get 2 times 12 plus 18 plus 6, and then that's 2 times 12 plus 18 is 30 plus 6 is 36. So what we should have seen is that our friend actually should have gotten 72 yards squared. This next problem, you have to realize that the big issue with it is that it's taking away one of the sides. So it says the inside of a baking pan is to be lined with tinfoil. This means that there is no top. So normally we would have we would do top and bottom. We would do left and right, and we would do front and back. But this time we're going to take out the top. It's not going to be part of our equation. So if we look at this, then here's how we do things. Let me see, I guess. Great. So we're going to just do the bottom, which would be 12 by 9. So 12 times, I'm curious. Do they have? I'm just seeing if there's Nope. Okay. It doesn't do it. I was just curious. So 12 times 9. But then we can add to that. We can go plus. And then now is when we double things up. 2 times 9 times 1.5 plus 12 times 1.5. And I need a calculator for this, so here we go. 12 times 9, though, is 108, plus 2 times, all right, we got 9 times 1.5. That gives us 13.5. I should have known that. Plus 12 times 1.5, I think it's 18. 12 times 1.5. That is indeed 18. So now we're going to add some things together. So we've got 108 plus 13.5 times 18 gives us 243. And then we're going to double that. 108 plus 486. And then that equals a final answer of 594 inches squared. So now remember, if you were 108 units higher, so if your answer was 702, you included the top, and that's the problem. So let's look at this one. Did our friend do this right? Well, he's got a radius of 4. That's good. Got a radius of 4. Got a height of 7. That's all good. 4 squared is 16. 2 times 4 is 8. Times 7 is 56, so that's good. 16 plus 56 is good. 72 times pi is roughly 226.8. Well, let me find that out. I don't know. 72 times 3.14. Yeah, your friend's correct. Awesome. All right, the graphing calculator. Estimate the total surface area of the calculator. So here we go. So this is just a square, or sorry, a rectangular prism. Duh. It's getting late. So 2 times 19 times 9 plus 19 times 2.5 times 9 times 2.5. That's going to give us 19 times 9 is 171. Oh, whoops, I need the 2 in front here. 2 times 171 plus 19 times 2.5 gives us 47.5 plus, and then we go 9 times 2.5, which gives us 22.5. So then we add these up. 171 plus 47.5 plus 22.5, which gives us 241. And 241 times 2, that should be 482. And that's centimeters squared. So that's for part A. Part B, it says the window of the calculator is 6.5 centimeters long and 4.5 centimeters wide. Estimate the surface area of the graphing calculator without the window. All right, so we're going to take out that window. So here we go. That window is 6.5 times 4.5. And 6.5 times 4.5 is 29.25 centimeters squared. So then what we need to do is we need to go 482 minus 29.25. And that's going to equal something. So 482 minus 29.25 gives us 452.8 centimeters squared. So that's the surface area without the window of the calculator. All right, a quarter is worth 25 cents and a $1/2 is worth 50 cents. Quarter has a diameter of 15/16 of an inch and a height of 1/16 of an inch. Find the surface area of a quarter, round your answer to the nearest hundredth. Let's remember that a quarter would be like a cylinder. So that means we're going to use the cylinder formula. So the surface area of a cylinder is 2 pi r squared plus 2 pi r h. So using the information we're given, we first have to stop and realize they gave us a diameter. Cretins! No, seriously, they gave us a diameter, and so we have to take half of that. Half of 15/16 is 15/32. Because if I multiply 1/2 by 15/16, 1 times 15 is 15, 2 times 16 is 32. So we're looking at 2 times 3.14 times 15/32 raised to the second power plus 2 times 3.14 times 15/32 times a height of 1/16 of an inch. Now, this gets wacky when you try to write it in the calculator, so you got to be careful here. 2 times 3.14 times I need to restart. 2 times 3.14 times 15 divided by 32, close that, and then square it. Oh, well, did that square it or did that take the square root? That's SQR. That's weird. And then press enter. I think that might be right. I'm kind of scared, so I'm going to double check this. 15 over 32 squared. Oh, it was right. So SQR is square for this calculator. I didn't realize that. Times 3.14 times 2. That gives me, I'm going to round that to 1.4. Actually, to be consistent with what I was telling you guys in class, I'm going to go 1.38 for the moment, plus, then I'm going to get this other mess. It's 2 times 3.14, whoa, 14, close that, open this set, 15 over 32, close that set, times 1/16. And voila. And that's 0.18. So if I add those two together, 1.38 plus 0.18, I get 1.56. So I'm just going to round that to 1.6 inches squared. Now, let's see what the next question asks. Whew. A half dollar has a diameter of 9/8 inches. Of course it does. And a height of 3/32 of an inch. Why not? Find the surface area of a half dollar. Round your answer to the nearest hundredth. Thank you. Thank you for making these numbers miserable. So here we go again. Same formula though. So second verse, same as the first, a little bit louder, a little bit worse. 2 times pi, 3.14. This time 9/8 cut in half, because they gave us a diameter again, because why wouldn't they? They like to torture us. So 9 times 1 is 9. 8 times 2 is 16. So we're looking at 9/16. And we're going to square that. Plus 2 times 3.14 times 9/16 times 3/32. So here we go. I'm going to do this backwards like I did last time. 9 divided by 16 equals that. Square it. Let me go back. 9 divided by 16 squared. And then we go times 3.14 times 2. So I get 1.99 plus, then we have 2 times 3.14 times 9 divided by 16, close that, time, that says 9/6. How do I fix that? I guess I can't. I can't go backwards, so I got to start all over again. Oh, wait, no, it cleared it. 9 divided by 16 times 3 divided by 32. So we get 0.33. So if I add those together, that's 1.99 plus 0.33. So I get 2.32. So I'm going to round that to 2.3. And that again is inches squared. Now, show that the value of the coin is not proportional to the surface area of the coin. So what that means is that 0.5 divided by 0.25, you hopefully know is 2. Well, if I take the $half at 2.3 and divide it by the quarter of 1.6, 2.3 divided by 1.6, we get 1.4 as a ratio. And so 1.4 is less than the 2 that we would expect it to be if they were proportional. So another way to do this, remember we could have done the whole like 0.25 over 1.6 equals 0.5 over 2.3, and we could have cross multiplied. So we could have said, hey, we've got 2.25 times 2.3, and that would have given us 0.575, and that does not equal 1.6 times 0.5, which is just 0.8. So either way you do that, you could show that they're not proportional. But then if the values of the coins were proportional to the surface areas of the coins, what would be the surface area of the $half? Round your answer to the nearest hundredth. Oh, shoot, I wasn't reading this earlier. Round your answer to the nearest hundredth. I was in dope. That's my fault. I don't think I can go back far enough. I don't see a history on here. Oh, there's a history. Can I go back far enough? Going back in time. So 0.33, that was good. 0.99, that was good. So that was 2.2. There we go. And then going back in time again helps to read these things. It's good that I can go back. 1.56. There we go. So there we go. These numbers still stay about the same, so I'm not going to worry about that. But round your answer to the nearest hundredth. So what we would have seen, if they were actually proportional, we should have seen 1.56 times 2, which would have been, drum roll please, oops, I hit times a half for some reason, 1.56 times 2, which is 3.12. We should have seen a surface area of 3.12 inches squared. All right, last couple problems here. This guy here, these are supplementary. So with them being supplementary, we're looking at x plus 34 equals 180. We subtract 180 by 34, or 34 from 180. I guess I should say it the right way. That gives us 146 degrees. Right here, these are complementary. So this should be x plus 74 equals 90. We then subtract 74 from both sides. 90 minus 74 is 16. And then last but not least, these are equal. So x plus 10 equals 59. They're equal because they're vertical. We subtract 10 from both sides and we get 49. Down here, last couple problems. Find the area of the circle. This is area equals pi r squared. I'm not going to keep writing this after this time because it's not worth it at this point. But area equals, and we're going 3.14 times 21 squared. So I go over to the calculator now. 3.14 times 21 times 21. That gives us, doesn't say what to round to, and there's only hundredths, so I'm just going to go for it. 1,384.74 inches squared. Here we have a diameter. So if the diameter is 36, the radius is 18. So that means we're going to go area equals 3.14 times 18 squared, which is a matter of number crunching. 3.14 times 18. Whoops. 18 times 18. And that gives us 1017.36 millimeters squared. And then last but not least, a radius of 8.5. And so that would just be area equals 3.14 times 8.5 times squared. So we look at this, 3.14 times 8.5 times 8.5. Whoops. So this equals 226.87 meters squared. I just thought about this. I just saw this. If you'd wanted to, you could have used 22/7 for this one. It'll be somewhere close to this, so you'll be fine. All right, so that takes care of all the story problems. So, all right, great.